Our starting DNA sequence is the following. The RNA polymerase will transcribe the template strand in the 3' to 5' direction to make an mRNA sequence in the 5' to 3' direction. If you didn't notice, this will be the same order of bases as the coding strand, except the T's will be U's. So for our purpose, I will use the coding strand to make it easier. In this situation, we are looking for a DNA sequence that will lead to 4 amino acids being coded for. So the coding strand is actually the bottom strand that is originally going in the 3 to 5 direction. So I will do a flip on that, and now it will be going the 5 to 3 direction. You replace all the T's with U's, and then you get the mRNA sequence. So our normal amino acid sequence without mutations is MVSK.
Point mutations are when there is a specific point of mutation, meaning that one base is substituted for another base by mistake.
A missense, also called a non-synonymous, is a type of point mutation where the alternate base causes another amino acid to be coded for.
So here, the codon GUC that used to code for valine becomes GCC, which now codes for alanine. This would be a transition because they are both pyrimidines.
This can have several different effects on the protein that should be formed. It may leave the protein non-functional, alter its function, or in some cases be neutral, meaning that the missense mutation does not affect the protein's function. Missense mutations are like when you are trying to text and you miss a letter, which is then autocorrected to a different word, messing up the whole meaning of the sentence.
A nonsense point mutation is where a base is altered and mistakenly turns a codon into a stop codon. Here, the codon AAG that used to code for lysine becomes UAG, which is now a stop codon. This is a transversion because it is going from a purine to a pyrimidine. These types of mutations bring an early end to the amino acid sequence because the faulty stop codon tells it to stop, so it renders the protein short and usually non-functional.
I like to think of these as kind of faulty stop signs. So it's not really supposed to be a stop sign, but it's like a villain in a cartoon or something painted over it and turned it into a stop sign, so you'd be stuck there forever. Silent point mutation is where a base is changed, but the mutated codon still codes for the same amino acid. Here, the codon AAG becomes AAA, which still codes for lysine. This would be a transition, because they are both purines. This point mutation should not affect the function of the protein that is produced. I like to think of the silent point mutation as the Bob Ross point mutation, because they're kind of like happy accidents. They still act the same way. A read-through is essentially the opposite of a nonsense mutation, because it is where a base in a stop codon is changed to something that now codes for an amino acid. This makes the protein much longer and can alter the function or make it non-functional. So here, the codon UAA, which used to be a stop codon, becomes a UCA, which now codes for serine. This would be a transversion, because it is going from an A to a C, so a purine to a pyrimidine. Read-throughs is sort of like a late night when you were supposed to be sleeping, but instead you were reading or doing something else, and then all of a sudden you look at the time and you're like, oh my gosh, I went way past what I was supposed to.